Hello everyone, welcome to the channel once again. Today we're unpacking a topic that honestly feels like absolute magic for software developers when you first see it in action, but when you look a little closer, it's actually just a highly efficient, automated factory. Welcome to our explainer on Maven, the powerhouse build tool. If you've ever wondered how thousands of lines of raw code somehow get transformed into the apps you use every single day, well, you're in the exact right place. We are going to break down this entire assembly line. I want you to think about this for a second. Developers don't just type a bunch of text into a computer, hit save, and suddenly have this finished, ready-to-ship product, right? There's a massive gap between writing source code and actually having a usable web or mobile app. That source code has to be converted, tested, and wrapped up securely. So the big question is, how on earth does that happen without developers literally pulling their hair out every single day? Okay, let's quickly outline our roadmap for this explainer. First up, we'll cover the build process. Second, meet Maven. Third, the assembly line. Fourth, the blueprint, which is the pom.xml. And finally, we'll see Maven in action. Let's dive in. Starting off with section 1, the build process. This is where we go from raw material to finished product. Think about the absolute manual burden of software development. For compiled languages like Java or .NET, the computer can't just read the raw text you wrote. First, that code has to be compiled. You use something like the Java C compiler, which translates it all into class files. But we can't stop there. Next, you have to run unit tests to make sure your specific chunk of code actually works and doesn't break anything. And if it passes, you finally package it into an archive. If it's a Windows program, maybe you're making an .exe file. If it's a Java web app, you're packing it into a .jar or .war format. Now, developers are constantly committing code, right? Imagine having to manually compile, manually trigger your test frameworks, manually run code analysis to find security bugs, and then manually package the files multiple times a day. It's just way too much work. Doing all of that by hand is painfully slow and super prone to human error. Automation isn't just a nice-to-have anymore, it's an absolute necessity if you want to maintain software quality and, honestly, developer sanity. Which brings us nicely to section 2, Meet Maven, the automator. So Maven is a tool designed specifically for Java source code, but it's part of a much larger ecosystem of build tools. Software architects basically choose their machinery based on the language they're targeting. For instance, if you're building a Microsoft's product, you're going to use MS Build. Building an OS executable like a Debian package, you'll use Make. Gradle is another really popular one that uses the Groovy format. But for a Java-based factory, Maven is the absolute gold standard. It largely superseded older tools like Ant because it requires significantly less manual scripting. Now, here's a vital prerequisite, and it's a gotcha that catches a lot of beginners off guard. Before Maven can do literally anything, you have to understand the difference between the JRE and the JDK. The Java Runtime Environment, or JRE, is totally fine if you just want to run an existing Java application. But Maven is building the software. Because of that, Maven absolutely requires the JDK, the Java Development Kit. Why? Because the JDK contains the actual compilers needed to transform your raw source code. Let's move on to section 3, the assembly line. Here we'll understand the build phases. Let's see how all of this builds a continuous pipeline. First, Maven validates your project structure. Then, it hits the compile phase, which actually translates the code. Next up is the test phase, where it runs your unit testing frameworks right against the source code to catch bugs early on. If those tests pass, it moves to the package phase, wrapping the compiled code into a final distributable format, like your .jar file. After it verifies the quality, the install phase downloads any required dependencies and places your final package in a local repository. And finally, the deploy phase pushes that finished package up to a remote repository where your DevOps engineers or your teammates can actually grab it. And this is honestly the genius of Maven's cycle stage design. I like to call it the domino effect. You don't have to tell Maven to run every single one of those phases one by one. If you just type the command to execute the package phase, Maven is smart enough to automatically knock down all the preceding dominoes. It's going to validate, compile, and run the unit tests first, totally on its own, before it finally packages your code. All right, section 4, the blueprint, configuring the machinery. POM stands for Project Object Model, and because it's written in XML, yes, it uses tags. But don't let the XML syntax intimidate you. Let's translate these technical tags into plain English. The artifact ID is basically just what you want to name your final output. Packaging tells Maven exactly the format you want, like a .war file. Properties are incredibly useful. They act just like variables. You define your Spring or MySQL version once right here, and it updates everywhere else in your project. And finally, Dependencies tell Maven exactly which external libraries and code packages your project needs to actually function. Usually, developers set this file up just once, and the build tool relies on it forever. Finally, Section 5, Maven in action. Let's fire up the factory. The real beauty of Maven is that its workflow is completely platform agnostic. Whether you're on an Ubuntu Linux machine using the apt package manager or a Windows setup using PowerShell and Chocolatey, the exact same steps apply. Step 1, install your JDK. Step 2, install Maven. Step 3, clone your project's source code repo using Git. And Step 4, just run the command mvn install. Boom. The factory starts humming, following every single rule you laid out in that pom.xml file. Now, when you run that install phase, something really brilliant happens behind the scenes. Maven reaches out to the internet, hits remote Maven repositories, and downloads all the external dependencies your project needs. But to save you a ton of time on future builds, it stores them all in a hidden folder in your user directory called the .m2 repository. Think of this as your local parts warehouse. The next time you build your software, Maven checks that .m2 folder first. If the parts are already there, it skips the download completely, making your subsequent builds incredibly fast. As Maven builds your software, it creates a folder called the target directory. That's where all the compiled classes and reports get stored. But if you build over and over again, old, stale data can get left behind in that target directory, and honestly, it causes some really weird errors. So by running the combined command mvn clean install, you're telling Maven to wipe the slate clean. It completely deletes the old target directory first, guaranteeing that your new build is perfectly fresh and totally accurate. So what is the ultimate goal of all this automated compiling, testing, and packaging? It's to produce an artifact. In Maven terminology, the artifact is the grand finale. It's your victory lap. It is the polished output, whether that's a .war file or a .jar archive that is fully baked and ready to be handed right over to your DevOps engineers to deploy to the live servers. Maven is obviously a massive leap forward from manually typing out compile commands, but it really is just one piece of the bigger puzzle. It handles the build locally on your machine, but it begs a fascinating question. What if a completely separate server, like Jenkins, could automatically trigger Maven every single time a developer pushes code, without a human being ever typing a single command? Well, that is the magic of continuous integration, and it is absolutely the next frontier of automation. Keep learning, keep automating. Also, if you like this explainer, please let us know and subscribe to the channel. We'll see you in the next one.